All right, so today we are going to talk about our second type of special right triangle. And so, what I wanted you to do before watching this video was to use the Pythagorean theorem to find the missing lengths in these triangles. And then these are the lengths that you should have come up with. So, I kind of wanted you to find one in each spot. And so, what we're going to do now is just kind of look at the relationships between these angles. And then, if we see any patterns between the angles and the sides. All right, so first we need to understand the relationship between the angles in these triangles. So they're all right triangles, and then the other two triangles are 30 degrees and 60 degrees. All right, so one thing we also need to remember is from first trimester. The shortest side is always across from the smallest angle. Okay. The longest side is always across from the biggest angle. And then the middle side is always across from the middle angle. Okay, so what that means is when we're looking at our triangle, our 90-degree angle will always be the biggest one if it's a right triangle. So that means the hypotenuse always needs to be the longest side. The 30-degree angle is always going to be across from the shortest side. And then the 60 is always going to be across from the middle side. So then we also need to remember the other vocabulary, that this is always called the hypotenuse, and that the other two sides are called the legs. So in this instance, we're going to be calling this leg the short leg because it's always going to be across from the 30-degree angle. So it's always going to be the shortest leg. And then this is going to be called the long leg because it's the longer of the two legs, since it'll always be across from the 60-degree angle. And so now if we kind of look at the relationship between the sides, notice both of these questions are related to the short leg. How do the short leg and this other side relate? So in terms of the short leg and the long leg, here's short, long, short, long, short, long. Hopefully you notice that this is a similar relationship to the 45, 45, 90 special triangles in terms of the radical 3. So the long leg is always the short leg times the square root of 3. And then the short leg and the hypotenuse, we've got 5, 10, 7, 14, 12, and 24. So the hypotenuse is always twice as long as the short leg. And so if you're looking at a 30, 60, 90 triangle, that's always going to be the relationship between the legs and the angles. We just have to understand how to work going from side to side. So 60 and 30. So if I put a variable that, so both of these again are related to the short leg. So I call the short leg like our home base. If you know that, you can really easily get the other two. So we're always going to be trying to find that short leg. And then this is going to be twice as long, and this is going to be radical 3 times as long. And that always needs to be our simplified radical. Okay. All right, so now we're just going to do a bunch of different examples here. All right, so if we look, let's start by labeling the sides of our triangle. Let me focus that a little bit better here. All right, and so across from the right angle is always going to be the hypotenuse. This is the 60-degree angle right here, so that means that this is going to be my long leg. And then if that's the 60-degree angle, that means that has to be the 30-degree angle. So that's going to be the short leg, which is good because this is like my home base side. If I know that side, I can get my other two. So maybe I'll kind of draw this blank triangle up here again so we can all see this relationship. So if that's our 60 and 30, that's x, 2x, and x radical 3. All right, so if we know our short leg, our long leg, which is x, is going to be radical 3 times as long. So x is going to be 8 radical 3. And then our hypotenuse is always going to be twice as long. So our hypotenuse would be 16. Okay. All right, and so now we're looking at this other triangle again. Let's label our side. So this is our short. So this is good. That's the one we need to know. There's our hypotenuse. There's our long. We're kind of labeling our triangle like we did when we did sine, cosine, tangent. It's just a good visual of like what sides do we know, which ones do we need. All right, and so for this one, now if I know my short leg is 1/2, the hypotenuse is always going to be twice as long. And so that means 1/2 times 2 is just going to be 1. And then y is always radical 3 times as long. So 1/2 times the square root of 3. I'm just going to clean up the way that looks really quick. We can always put anything over 1. And when we multiply fractions, multiply straight across the top and straight across the bottom. So 1 times radical 3 at top, 2 on the bottom. In this one, so now we know the hypotenuse. We don't know that home base side that we know. Oops, I should say long, not leg. So now we're going to be working backwards. So you have to think, all right, if the hypotenuse is always twice as long as the short leg, and this is 6, that means our short leg needs to be 3. And then my long leg, now that I know that, is always going to be radical 3 times as long. So that would be 3 radical 3. Okay. So we're going to do, and we're going to add a couple more examples just because we didn't really do any that involve knowing the long side, because those can sometimes be the trickier ones. And so here again, we know the hypotenuse. There's my 30-degree angle, so that's going to be the short. 60 is going to be the long. So we're again kind of working backwards here. If this is 10 and this is twice as long as this, that means that C is going to have to be 5. And D, that long leg's always radical 3 times the short. So that would be 5 radical 3. All right, so I'm going to add 2 more. Let's do this one. So my 60-degree angle is right here, and here's my X and my Y. And let's say that this is 12 radical 3. Okay. All right, so if this is my long leg, because it's across from the 60-degree angle, that means this is going to be my short, and that's going to be my hypotenuse. Okay. All right, so if we go up here and think about, okay, so what is the relationship between the long leg and the short leg here? And this one's going to be a little bit easier because of the way that this information is given to me. It's given to me with the radical 3 in it. So if we think, all right, if this is always x times the square root of 3, and that's just x, that means that this short side is just going to be 12. So I'm just going to take off that radical 3. Again, just kind of like I did with the 45, 45, 90. So I'm just working backwards here. And then that means the hypotenuse would be 24. 2 times as long. So now we need to think, all right, well, what would happen if my long leg didn't have that radical 3 in it? Okay, that just means your short side and your hypotenuse will have a radical in it. So let's say I told you that this was 18. So now I need to figure out the short leg and my hypotenuse. So we need to figure out what did we multiply by radical 3 to get 18. So that's kind of like my equation. Whatever my short leg is times the square root of 3 is how I got 18. And as we kind of go through solving this, think about the patterns and the relationships that we kind of figured out when we did the 45, 45, 90. So if I'm solving for that short side, which is always what we're going to be solving for, again, because that's my home base side, that's what's related to the other two sides. So we're never really going to go from long leg to hypotenuse. We're going to take that middleman to get there. And so I have to divide by radical 3 to get that x by itself. You can't have a radical in the denominator of a fraction, so I'm going to multiply by that radical. So that gives me 18 radical 3 on top, and then the radical will cancel, leaving me just with the 3 on the bottom. And then we can divide that out. So 18 divided by 3 is going to be 6 radical 3. So again, look at the relationship between the 6 radical 3 and the 18. It's exactly the same as it was with the 45, 45, 90 when our hypotenuse was a whole number. We divided it by 2. That was what went on the outside, and then we kept the 2 underneath the radical. It's the same thing here, except now we're dividing it by 3 because we need that radical 3 underneath. So if that had been a 21, that would be 7 radical 3. If that were 24, that would be 8 radical 3. If it's not divisible by 3, so if it had been like 14, if the leg had been 14, then it would be 14 over 3 with that radical 3 up top. Looks a little bit messier, but it's the same idea. Okay. And so then if my hypotenuse is twice as long, so if we think, all right, if I have 6 radical 3's here and 6 radical 3's here, I've got a total of 12 radical 3's. So you don't multiply the part underneath also by 3, just the outside. All right, so now let's look at this last one, this kind of extension problem, kind of similar to the perimeter one from our other lesson. All right, so this says the sides of an equilateral triangle are 10 centimeters. 10, 10, 10. Okay. So to remember that equilateral triangles have 360-degree angles. And this says find the length of the triangle's altitude. So remember, the altitude is the segment drawn from a vertex straight down to the other side. So that creates a 90-degree angle here. And if this angle is 60, then based on the rules about angles in a triangle, that has to be 30. So if I want to know the length of the triangle's altitude, I can use the properties of 30, 60, 90 triangles to do that. So just to kind of uncomplicate this picture, I'm going to draw just this triangle. So that's the 10. This is what I'm looking for. So this is my 30-degree angle. That's going to be, or make this my short side. That's across from the 90-degree angle, so that's the hypotenuse. So the short leg is always half of the hypotenuse, and then the long leg is always radical 3 times as long. So that's going to make the altitude 5 radical 3 centimeters. All right, so your homework tonight is this worksheet that was in your packet. And so it gives you kind of, again, the relationship here, and then just a bunch of practice problems. Make sure all of your answers are left as simplified radicals with work shown when necessary. And then just hop on Canvas conferences if you have any questions.